Ladies and gentlemen, welcome to the first video of a series of videos that will concern high-performance liquid chromatography. That's a mouthful, right? High-performance liquid chromatography. Try saying that 3 times fast. Well, HPLC is our code for high-performance liquid chromatography. So you're watching this video, which is only one of many, because you're either a student or you're a teacher that wants to know more about the HPLC instrument. The reason is because this instrument is a focus of the Chemtechathon competition that's being held at Cape Fear Community College. A little backstory about how this all began. Each year we meet with our advisory committee. This advisory committee is made up of local employers in New Hanover and Pender counties. And for this year's competition event, these employers voted that HPLC is the most important instrument that we can provide you exposure to. And these are from the employers that work in the field. So they strongly believe that if you are interested in a science career, or if you are interested in coming through the chemical technology program at Cape Fear, or if you're interested in graduating from high school and going on to a 4-year school or university and majoring in a science, that you will eventually come across an HPLC system at some point in your studies, whether that's at a community college level, a 4-year school, a university level, maybe through a cooperative course or an internship class, or maybe when you finally get a job in the field. HPLC is one of the most common instruments that you will see these companies use on a daily basis. If you take a look at Merck Pharmaceuticals, and you look at how Merck has treated HPLC analysis, you will see that they have almost basically purchased an HPLC system for every single person that needs to run HPLC in the lab. That way, when you need it, it is available for you to use. So many things can happen with high performance liquid chromatography, and that's the purpose of this series of videos, to tell you a little bit of history with the instrument itself, with the theory of how the instrument works, the theory of what started all of this mess to begin with in the early 1900s, and how we've progressed and led up to the point that we are today. And then we will have a couple of videos that will focus on instrument pieces and parts. What are the pieces and parts that make the instrument work? How do they all talk to each other? And what can we do with the data analysis that happens in the very end of the instrument? Okay, so without wasting any more time, let's just go ahead and start off with an analogy. And let's pretend that this analogy, you are given the task to separate a crate of bees and wasps. Well, I don't know about you, but I wouldn't want to be given the task to separate bees and wasps from each other. Are you crazy? What do you want me to do? You want me to open up this box and what? Take a pair of tweezers and start grabbing a hold of a bee or a wasp or whatever I can get a hold of first and set it over into a container and put a lid on it really quick? And you want me to do this for the entire crate? No, this is crazy. This doesn't make any sense. Who on earth would want to go through the process of separating things like this one by one? Not only that, but these are bees. They're going to sting me. And depending on how many times I get stung, I could go into the hospital. So this is not an ideal situation for me. So if I gave you this task in a lab, you better look at me and say, "You're crazy. This is not going to work." So there's got to be a better alternative. Well, molecules are the same way. You can't grab a hold of a molecule with a pair of tweezers and begin to separate the molecules from each other and put them in separate containers. It's just not going to work out for you. Good luck, but it's not going to work. So there's got to be a better way to separate things. And if I could maybe play off of how they act together, or with each other, or with something else, then maybe I could streamline this process, be a little bit creative, and come up with a method, a technique that will separate these two things from each other. And that way I can just step back and let these bees and wasps do their own thing and separate off together on their own, and I don't have to be involved in that process. That is the beauty of chromatography. And that is what chromatography does. It separates. Whatever type of chromatography instrument that I'm using, it doesn't matter. If it's high-performance liquid chromatography, if it's gas chromatography, if it's ion chromatography, size exclusion chromatography, thin layer chromatography, affinity chromatography. Chromatography is just that. It separates. Okay, so let's take a look at this analogy. Let's take a look at this problem with bees and wasps. So first, I want to talk about what this term chromatography really means, because we're going to be using it a lot, and if we're going to be using it a lot, we might as well understand really what it translates into, right? That makes sense. Why do I want to use a word if I don't know what it means? So if I look at chromatography, and I kind of split this word up into two pieces, the first word is chroma. And if I take a look at the word chroma, well, this typically makes people think color. So chroma means color. Tography is just another word for writing. So chromatography means color writing. And this is how chromatography began back in the early days of its birth. Color writing is what chromatography focused around. No longer, though, do things have to be colored in order to run them on chromatography. But this is the origination of the word back in the early 1900s, when we get a guy that goes into a lab and begins the first chromographic method. And we'll talk about him, and we'll talk about that process eventually. But right now, we want to focus on our crate of danger. And that is the bees and the wasp. Okay, so I told you, we need to be creative. If we want to separate these two things from each other, we need to be creative about the process that we do it with. I don't want to use a pair of tweezers. So what if I have a tunnel? And this tunnel, I'm going to stand on one end of it, and I've got my crate of bees and wasp, and I don't want to take a pair of tweezers and separate them from each other. I want this process to happen as naturally as it can. So hopefully what will happen is that I can stand at the end of this tunnel and I can open up the crate. And if I open up the crate, then all of the bees and wasps will fly out of it. And hopefully they all go inside of this tunnel. That's where I want them to be. So inside of the tunnel, I get all of these things that are flying around. Bees are flying around and wasps are flying around, and they're having a great old good time. So here's a bee, and there's a bee, and here's a wasp, and there's a wasp. Okay, well, if I just let them fly down the tunnel, nothing's really going to happen. They're just going to fly down the tunnel, and they're going to go out of the other end where it's sunny and green, and then they're going to have a happy little life and, go and do whatever they want to go do. Nothing really is going to happen. But if I modify the tunnel, then I can change things up a little bit. Okay, well, what does this modification mean? What do you mean modifying the tunnel? Well, if I can look at bees and wasps, and if I can play off, they're similar, but if I can play off on their differences, then maybe I could change this whole process and work it in my favor. Okay, so one of the ways that bees and wasps are different is that maybe on the bottom of this tunnel, I can put some flowers, some pretty little flowers. And what will happen is that the bees will love the flowers. The bees will kind of stop in their tracks, and they'll see the flower at the bottom of the tunnel, and these bees will go to the flowers, and they will hang out for a while. They will talk about what they did on the weekend. They will take their time and just enjoy the day, and then when they get done with that flower, they will go to the next flower. And then when they get done with that one, they will go to the next flower. And they will take their time, and they will make sure that they will not leave out any flower along the way through the tunnel. But the wasp just really don't care. Those flowers at the bottom of that tunnel doesn't mean anything to them. So they're not attracted to the flowers at all. And because of that, they're not going to hang out with their buddies on the flowers and talk about what they did on the weekend. Instead, these wasps are just going to zoom straight through the tunnel. Eureka! I have solved the problem. I don't get stung. I don't get hurt. I don't get sent to the hospital. I have separated maybe the wasp from the bees just by looking at what I can do inside of this tunnel. Okay, well, really, on the other end of this, hopefully I will have a buddy that will volunteer, and this buddy will have maybe a counter or a ticker. So when the wasp come out of the other end of the tunnel, my buddy can be at the other end of the tunnel, and he could start counting the number of wasps that he sees escaping from the tunnel. And not only that, but maybe I could give him a huge plastic bag. And this huge plastic bag, I would tell him, when the wasp come out, I want you to collect them. So he's waiting for the wasp. The wasps are getting collected at the end of the tunnel because they're not attracted to the flowers, and then he is clicking one after another as they come out to count them. Okay, well, after the wasp leave, he kind of is tapping his finger like, okay, bees, where you at? Why are you taking so long? You need to come on out of the tunnel, please. And then eventually, slowly but surely, these bees make their way to the end of the tunnel, and they begin to leave. Well, my buddy at the other end, he's going to be counting the number of bees that come through, and he's going to make some tallies with me. And then I'm going to give him the same objective. I'm going to give him a big plastic bag, and this bag is going to capture all of the bees that come through. I've just separated my wasp and bees from each other. This is what chromatography does. Except for bees and wasps, we use compounds. Compounds that might be similar but slightly different in nature. And if we can play off of those compounds' differences, then we can get creative with our tunnel, which is found inside of the machine, and these compounds can begin to separate on their own. I can't give you a pair of tweezers and tell you to separate molecules from each other. But I can give you a tunnel, and under the right circumstances, this tunnel will allow me to separate these compounds one by one. And that is the power of chromatography. So in the next video, what we will talk about is that we will pick up from this point and we will go back and talk about this term chromatography. How did it really get all started? It wasn't with bees and wasps. What molecules were going on? And what did the scientists do back in that day to separate things from each other?